All right, everybody, welcome back. So here we are in section 3.1. And in this chapter, we're talking about power equations. Okay, what all men crave, power. So we saw in chapter, where's the pen? Oh, plugged in. Okay. We saw in chapter 1 that we had, well, there it is. We had linear equations, and their basic template was y equals mx plus b, or ax plus b. It doesn't really matter. Then in chapter 2, we saw quadratics, and their basic template, their basic formula, whatever you want to call it, is ax squared plus bx plus c. Okay. Now, with power equations, why won't my mouse work? Maybe that'll do it. There, that did it. Okay. So with power equations, we have something that looks just a little different. Okay, we have, let me write it here. Okay, power equations, it'll be y equals a, whoops. No, yeah, I'm doing it right. Ax to the b. So it's a little bit similar to quadratic because, just like you had an exponent there, you got an exponent here. But this time, the exponent can be whatever, okay? It could be 1.32 or 6.95 or whatever, okay? But you're still going to do it the same way on the calculator, so it's not going to be a big deal, okay? You'll plug all your data in later on in the chapter, and then it'll tell you the A and the B, and then you just plug them right in. So anyway, so that is the template for chapter 3, okay? So that's where we're going. All right, now on number 6 is the temperature of a closed car shown over time on a day that is 80 degrees. So our X values are how many minutes the car has been outside on it's 80 degrees outside, and the windows are up because it's closed. At least I'm assuming. It doesn't matter. And so what's the internal temperature? Well, 1 minute after uh, after the experiment starts, so like 1 minute after you get out of the car, okay, it's about 80 degrees inside the car. All right, you probably had the AC on, so the temperature's, coming up from 72 to 80. After 10 minutes of leaving the car alone, it's up to 99. So the first 10 minutes, it cranks up. And I think we've all experienced that. After an hour, it's 123 degrees in there. Yeah, you could handle that, but not for too long, and especially not without, a bit of water. Okay, so that's kind of what's going on. So make a graph of the data, and blah blah blah. Choose axes. Okay, so let's get to it. And so here's what I'm going to do. I'm just going to take a picture of the data with my phone, and then I don't have to click back and forth. How's that sound? Okay. So I'm going to use Microsoft Word because I'm not the most impressive guy when it comes to this stuff. Okay, so there is our y-axis. There's our x-axis. And let's see. Let's start writing some stuff in here. Okay, so we said that the x-axis, that's minutes, so it's good to label it. The y-axis, that's temperature. Okay, and the x-axis went, it basically started at 0, okay, and 0 minutes, and it went up to an hour. So I'll just use the full width there. So halfway across, that'll be 30 minutes, and then halfway there is 15, and halfway there is 45. I just need a few of those little markers there to give me an idea of where I'm at. Or I could go 10, 20, 30, 40, 50, 60. I didn't think to, otherwise I probably would have, but whatever. Okay. Well, we probably don't need to go all the way down to 0 degrees Fahrenheit. I mean, that's well below freezing. We start off at 80, so I guess let's just, go at 80, and then it goes up to 123. So I don't know, I'll go up to maybe 130, and then I'll just go up every 10. So maybe about there is 90, 100, 110. And okay, it's not perfectly drawn. Okay, this gap here is a lot bigger than that gap there, but okay, I'm doing my best here. Okay, so I'm supposed to graph all the points. Okay, so where did that one cool thing go? You know what? It's September, so I'm going to use hearts. Okay. Um, so the first one is at 1 minute, 80 degrees. So 1 minute over is about there, and then 80 degrees Fahrenheit. So about there. All right. Then we've got at the 10-minute mark, which is about here, we're at 99 degrees. Whoa. Okay. Then at the 20-minute mark, we're at 109. So 20 minutes going to be about here, 109 degrees, about there-ish. All right. Then at the 30-minute mark, we're at 114. Hooray for extra hot. Okay. At the 40-minute mark, we're only at 180. I was going to say 180. Yeah, that's all. At the 40-minute mark, we're at about 118. So not much of a jump during that 10 minutes from 30 to 40. But that's okay. That's the way things work. You wouldn't expect the temperature to just keep increasing at the same rate, just a straight line. It's like, yeah, if it gets infinitely hot in your car, it's like, well, that doesn't make any sense. I mean, there's got to be a limit. I mean, it's not going to be 10 million degrees in there eventually. All right, next would be the 50 at 50 minutes. It's 120 degrees. So 50 is about here. And then 120 is not much more than that 118. And then the last one, the 60-minute mark, we're at 123 degrees. So about right there. Okay. All righty. So there, I've made my graph, and yeah, I feel pretty good about that artwork. Pretty slick. Okay. So part B, find the slope between 10 and 20 minutes and explain the meaning of the slope in context. Okie dokie. All right, so I'm going to use the data at the 20-minute mark and the 30-minute mark, except I'm going to go back here so it's easier to read. Okay, so it's going to be, so the slope, this is part B. So the slope M is going to be the difference of the Y values, how much the temperature increases, divided by the difference of the X values. Okay, so the temperature increases 5 degrees for every, during that 10-minute interval. Okay. I mean, it'd be really different if it was the temperature went up 5 degrees over 200 minutes. It'd be like, oh, over 200 minutes, the temperature is going up, but not nearly as fast. Okay. So if we divide that out, we get 0.5, 1/2. Okay. But we are supposed to tell what this means. Okay. So I'm going to go here and say, whoa, those are really big. I don't need that big. Let's go to about there. Okay, so let me redo that. So it's there. Okay. So what does the 0.5 mean? Well, like we saw in chapters 1 and 2, how to interpret slope, it would mean the temperature increases by 0.5 degrees each minute. Now, that's a really good answer, but to be honest, it's not as good as it could be, or in other words, it's not as accurate as it could be, because like we talked about when I was designing the graph and I was putting it all together, the temperature isn't increasing by the same amount every 10-minute interval. Okay. And by the same token, the temperature is not increasing the same amount every minute, even every minute during a single 10-minute interval. So it would be more accurate to say the temperature increases by an average of 0.5 degrees each minute between the 20-minute mark and the 30-minute mark. Okay, because if you go find the slope for another interval, that's probably going to be different. I mean, it might not be, but it probably will be. So that is what we want. Okay. Now, part C is really similar, so that's kind of nice. Let's see. Part C says do the same thing, but from the 30 to the 40-minute mark. Oh, it said 10 to 20. Whoops, I did 20 to 30. All right, whatever. I did 20 to 30. Okay, let's do the 30 to 40 minute mark this time. Okay. All right. So 30 to 40. Where's my there? So the slope is going to be 118 minus 114 over 40 minus 30, which is 0.4. Oh, we got a different answer. Okay, cool. So I mean, and so my explanation is going to be very, very similar. All I'm going to do is say, okay, well, the temperature, it goes up an average of 0.4 degrees because it's different each minute between the 30-minute mark and the 40-minute mark. And that's the only difference I'm going to do. Okay. For my explanation. But that explanation is really important because it means you understand what's going on. Okay. If you don't get why I threw in those extra words, by an average of and all that, study it, contact me, let's talk about it because it really is important to understand this what's going on. Okay. All right. Now let's go back to the problem here. Let's see. Okay, part D. Add a trend line to the graph. Yeah. Okay, cool. All that means is I just draw it the best I can. All right, but first let's clean this up just a wee bit. There. Okay, so my trend line is going to look about like that. Okay, and so and I'm graphing a power model. It looks a lot like one half of a quadratic of a parabola from chapter 2, but it's technically not. Although you have to kind of get into the nitty gritty of the equations in order to see the difference. But all right. So let's see. All right, so I drew the trend line. Everything's wonderful. So then part E says, all right, now let's use this information, although we kind of did that with our explanations in parts B and C. Okay, if 105 degrees is considered unsafe, read the graph to estimate the number of minutes it takes to reach 105 degrees. All right, now normally we don't, we wait till the third section of the chapter to be given a Y value and then find an X value. Okay, but we're not going to use the equation to find that X value here. We're just going to use the graph, and we've already seen how to do that. Okay, so all right, so let's do it. So I'll do this, and then I want a new color because it's fun. Okay, so 105 degrees, that's right there. Okay, and I'm trying to get it nice and level. I know it always moves when I pick up my pen, whatever. Okay, when does that happen? Well, according to the graph I drew, which is not perfect, it looks like at about maybe, I don't know, maybe about 17 minutes in, maybe, and, we're all going to get probably a slightly different answer. We should all be close to each other, but if we're all slightly different, that's okay because we're estimating off of a graph that was drawn in perfectly. So definitely a lot of estimation there, but that's the idea. So probably about, I don't know, 16, 17 minutes, somewhere in there. So anyway, that would be my answer. So about the 17-minute mark, that's when we're going to hit about 105 degrees. So, something to bear in mind. Anyway, that's all I got for this one.